Okay, so here we have the biogenesis side of this chart. And biogenesis, like we said, comes from the sediment comes from life. So there's two different chemistries that we can talk about. We can talk about calcium carbonate and we can talk about silica. So if you look down in the bottom right-hand side of this slide, you'll see a small photo that has fossiliferous limestone in it. And fossiliferous limestone is a rock that is primarily composed of shell particles that have the organism that was living in the shell had either died or they had outgrown the shell and the shell had fallen to the seafloor. After billions and trillions of those had fallen and the weight of them had compacted them, had lithified them, they became a sediment, a sedimentary rock, known as limestone in shallow waters. The picture on the left shows these shells, before they have been compacted. Now, in this case, the size of these particles is not dependent on where they're found. Where they're found is not dependent on their size. It's their chemistry. In warm surface waters, you find calcareous, calcium carbonate-based sedimentary rocks, and in deep, cold waters, you find silica or quartz-based sedimentary rocks. The reason for that is due to the water chemistry at depth and how it changes based on the photic zone and the amount of acidity and the temperature of ocean water. So we'll talk more about that later when we get into the calcium compensation depth, which is the CCD, as mentioned in the chart there, and when we talk about different layers of water in the ocean.